So SAP HANA is a platform. Like when I say it's a platform, then what are the other capabilities that comes into picture, right? So like it has application server where you can it provides a platform where you can develop your own apps. You can develop apps on whatever means open sources you have, whether it be a .NET or Java or anything. Also, you can use HANA for ELT purposes. Like you have sources from different. It can be any database. It can be any data sources. You can use those. There are some ETL capabilities of SAP HANA. So you can just to take those data from those different sources, and you can process the data into SAP HANA as per your need. So it is more than a database. So now how the architecture of SAP HANA differs like from other database we have in the market. Why the customer will spend so much on SAP HANA? SAP HANA is very costly. So the thing is, first we will see that the challenge we have in this IT world is first the volume of data. So as you know that now lot of data are being generated, and the issue happens when you try to analyze this particular data. Moreover, like what happens if, for example, you have a OLTP database or OLTP system. So generally, as per the scenario, what happens is if you want to generate a report, then you extract the data from OLTP to OLAP, and from there you will be having the reports. So what happens is the time you got the data on your particular dashboards or reports, it is actually old data. Maybe it's old, not very old. It can be like 5 minutes, 10 minutes, even 20 minutes old, because that it takes time to extract the data from OLTP. Then it comes to OLAP. Then a transformation happens. Then you get the report. So for some of the businesses, maybe this particular data is obsolete, where real-time reporting is needed. So this is all of and also like when you have a huge amount of data, then if you go for the traditional database, then obviously the data processing and everything becomes very slow. So this is where SAP HANA came into picture. Also, I would like to say I will be following some of the documents which are like very SAP standard documents. These are TADMs. These TADMs you can follow for your certifications because these are SAP official documents. I can share the documents after the end of the course. It says over here that SAP HANA is flexible data source agnostic appliance. What does it mean? As I said that for SAP HANA, like you can extract data from different kind of data source. It can be a Hadoop, or it can be Oracle, or it can be any legacy system. So it fits with any kind of data source that you have. It has that particular facilities. It has that ETL capabilities. This second point says that SAP HANA is hardware and software combination that integrates number of SAP components. And if you see, it says SAP database and several other capabilities that it has. Like for example, you will come to this later on. Like apart from the database, you can use it for other replication factors and all. And the third point, if you see, it says it's a hybrid database. I think you guys are aware that I saw that everyone was saying it's a columnar database, but actually it's not only a columnar database. It supports both. That is the reason SAP HANA acts as both OLTP and OLAP database. But yes, it stores a maximum of its data as a column data, and makes the system data and all these things are stored as row. But it has the capabilities to store both kind of, you can store the data in a columnar or as well as row store. When you are storing the data, you also have an option to put it the way you want. So that is why they call it, they says that SAP is like a hybrid database. So you can use it both as a OLTP and as a OLAP. So you don't need, now you don't need a separate database for OLTP and OLAP. The same database, you can use it as a OLAP as well as OLTP. So this is the reason that if you will get whatever reports or the data on the reports you get, it is like very real time kind of data. Now, if we come to the innovations that has been done to SAP HANA in terms of hardware technology, see, it's in terms of hardware technology, I won't say that this particular hardware technology is very much constant to SAP HANA. It's like a hardware technology that is available to any database, to any servers. Like we have multiple cores, and like we have now, it isn't 10 cores, but now we have like 18 cores as well. But what we have to look more from the SAP HANA perspective is the software capabilities that SAP HANA provides. That is, first is it offers you both a row and column store. The second is the compression. Third is the partition. Fourth is no aggregate tables. And the fifth will be the insert on delta. So we'll be going a bit detailed on all these topics. Let's discuss like what exactly is a column store and row store. So this is what I was discussing. If you see, this is the bottleneck. You have a lot of data, and the bottleneck happens with the I/O. So this is where SAP HANA came with innovations like how to tackle with huge volume of data so that the bottleneck doesn't happen. So what SAP did is they are, instead of keeping the whole data onto the disk, they are putting the data into the memory, like on the RAM itself. But yes, it's not like it is having the data only onto the memory; it is having on the disk as well. We'll discuss on this on the next later on. So like you have idea on column store and row store, right? So yeah,
Yes.
if you see this particular table, let's take whatever data we have, like if we put it into a table. So when it goes for a row store, it will be storing in this way. And if you go for a column store, it will be storing this way. So generally, OLTP will be storing the data by row, and OLAP will have it by column. Why? Because when like for OLTP, there will be multiple and very high frequently insert and delete and all this. So this particular insert, delete, this particular operations are easy when you are storing the data in a row. But for example, when you want to have aggregate or you want to have a report, in that case, if you see, if you want to do an aggregate in a column base, all that same kind of data are being stored together. So doing aggregate, it becomes easy because you can find the whole data within a single linear search. So this is how what happens is SAP HANA is actually more effective if you're using it for reporting purpose because it stores maximum of its bulk of its data by default as column store. Now here it says like, for example, as I said, when you are storing data, you can have your own application logic or you can have your own programs which says how the data has to be stored, whether you want to store it as a column store or you want to store it as a row based store. So this is where actually it gives you an idea like how to decide which kind of store you will choose while storing the data. So it says like if you have data which is very distinct, so in that case you can choose a row based store. And if you see that all the columns are relevant, like for example, if you have to retrieve a data which will require all the columns data, in that case you can put it as a row store, and no aggregate or search is required, and table has a minor number of records, then for all these cases you can choose the data to be stored as row based. But if you want to for column based, we have like if you have a large number of rows where columns based will be processed, in that case you can choose. And if you have a large number of columns, obviously, so that the compression will be good. And if you want to have analytical like reports and all, which will obviously the linear search and everything will be easy, so in that case we'll be using a column based. This is just a picture of the HANA Studio. I don't have the system access as of now. If I have the once I have the system access, I can show you exactly where you can get all this information from the HANA Studio. Now, when it comes to now, let's go to the compression part. We'll see the compression with this particular example. This is a particular table. we can see how the compression works actually. Now, if you see for this particular table, there will be another table which they will use it as a key. So as you see for this for customer column, we have 100 twice and 200 and 300. So what happens is there will be a particular index that will be maintained. So for this, we'll have only one entry of 100 and 200 and 300. So if you see, if we have more distinct values, then the compression is not that much, as you see in column 1. But if you see in column 2, we have distinct values. So in that case, the compression is better. It is 50% almost. So this is the reason if you have similar values, or if you have similar kind of values which are being used for reports and all for aggregates, so in that case, if we have a column store, it helps us. But if the values are distinct, if you see the column 4, so it doesn't help much because you cannot compress the data in that. Now, when it comes to partitioning, like SAP HANA, as we have multiple cores, all this partitioning is supported by other databases as well. But in SAP HANA, the features we have that you can have multiple tables spread across different cores. Even if you want, you can partition a particular table on the base of columns also. It's not only that tables are being put in different partitions. For a single table, if you have a table which is like more than a, maybe it can be more than a 100 GB or 200 GB, you can partition that on the basis of tables also. So when you do the partition, how it helps is like each and every partition is being treated by the course as a individual table. So what happens? We will have massive parallel processing. So this helps us if you partition the table, and it will help us of getting the data to be processed very fast. Now, what is insert only on delta? So as you know that SAP HANA, as I told, that holds maximum of the table as a column based, and it's highly compressed. Now, what becomes challenging for us when you want to do insert or delete on a compressed data? So what happens is, for example, when the data is compressed, you cannot do direct delete or insert in that particular data. So if you have to do that, first you have to uncompress the data, you have to delete, and then again you have to compress it, right? So for this, what SAP has done is it has provided two memory, you can say. So for a particular, let's take for a particular table, it will have a main memory where actual data of the particular table will be stored, and it will be highly compressed. Now there will be another memory for the same table which is known as delta. What this delta does is whatever write operations you'll be doing, like for example, in a particular table you are deleting a data or you are inserting a data, that particular operations will be happening on this delta part of that particular table, not on the main part. Why? Because if you want to do, or if you intend to do the same delete or insert any kind of write action on this particular main data, then again the processing becomes slow. Why? Because you have to uncompress the data, you have to do the operations, and then again you have to compress the data. So avoid this, what SAP has done is they have provided a separate storage. So whatever write operations, delete, or whatever you have to do, you just do it over here. Now the database has its own mechanism. So when what it does is, once there are some criteria, like when these particular criteria are met, it will merge the main data and the delta data. So then you will have a consistent main data, which will be having the particular changes that you did. But yes, the question comes, for example, if I have done some changes and somebody I've saved my changes, and parallelly somebody is reading that particular table, so obviously he should be able to see the latest changes, right? Now for example, if we are allowing only from the main storage, then obviously that particular person won't be able to see the changes that I did. So this will form inconsistency in the particular data. So for this purpose, what HANA does is it will allow read operations to allow from both the storage. So what it does is, when you are doing any read operations, it will read the data from the main and the data, and it will consolidate and it will show the updated data. So this is how SAP HANA tackles with the challenges that you have with a columnar database. If it's only a columnar database, so these are the challenges you have with inserts. So this is how SAP HANA tackles it. With HANA, what happens is, as you have a background from SAP, so if you see, like when a particular application, I'm saying about SAP, but it's same for other applications as well. So whatever applications logic we have is on mainly on the application layer. So for example, when you are doing any particular transaction or anything, so what happens is, for it will fetch the data from the database. It will do the calculation. Then again, it will write the data into the database. Again, there will be some independence on some other tables. It will read the data, and with the application logic, it will do some calculation, and it will put the data back to the database. So in this case, if you see, a lot of IOs are happening between the application as well as and between the database. So with HANA, what optimization has been done is, HANA has its own engines. It has some application logics. So with this, what happens is, it push down this application logic, this particular calculation and all, to the database layer, where exactly the data is lying. So what it does is, it will do the calculation, it will do everything, and it will just send the result to the application layer. So in this, what is happening is, the IO between the application and the database reduces. So this will help you in having any data or anything very fast. Now for this, to adapt this particular feature of SAP HANA, obviously you will have to optimize your application layer logic. So if you see from 730 NetWeaver and 740, SAP already made this particular changes. So when you are installing a SAP HANA, there are some bodies which will detect that it is SAP HANA, so we will follow a different logic. If it's a traditional database, it will follow different logic. So this is the software optimization that they have done. So this is what I actually explained. So if you see the application layer, actually in application layer, the calculation in traditional applications, if you see, the calculation will be here, data will be lying on the database layer. So with SAP HANA, what has been done is, the calculation will be done directly on where exactly the data is lying. So this will help us some of the traffic that are happening between the application layer and the database. So this is what I was saying in terms of SAP. If you see, when you are running anything, a particular app code will be run. So that particular body will decide whether, like, it's a traditional database or it's a HANA database. So accordingly, the application logic works. Means this is how SAP deals with SAP HANA. This is what we discussed. The same thing, the calculation, the data, the code for the particular, whatever codes you are writing, the calculation logic. Previously, it used to be on the application layer. Now it is being done on the database layer, which helps is in processing the data very fast. Okay, fine. So this is we have from the just overview on the SAP HANA.
You said the data is stored in the main as a compressed state, and where the writing things is happening in the delta states, right?
Correct.
So both the datas are same, or does the where the means where the changes are made in the data, that data is only fetching to the delta part.
No, in the delta, only the changes are being maintained. Because see, if you
So
have to maintain both the memories, both the table, like in the main and the delta, then obviously the size, first of all, the size of the database will be double, right? So it doesn't make sense. So
yeah,
this is just storing the delta.
I'm just being confused because both the data are just same, right?
No,
In
no,
main
no. See,
data.
no, I will tell you. Like in the
Yeah.
main, you have the whole. In the main, you will have the whole table. Okay. Now, for
Okay.
example, if you are doing any changes and all, so it will be written to this delta. Only the changes.
Yeah.
Now, when
Okay.
the merging happens, there are will come later on. Like how means when the merging will happen and all. When the merging happens, then in this main will become a new main. Let's take m dash. Then the m will have the new change data that you have done. So in the meanwhile, when the delta is lying on this particular delta memory and the main is lying, if you are reading the data, it will happen from both, but writing will happen only on the delta.
Okay. So it will take only one data at a time.
I didn't get it. One data at a time means?
Means one whole data means where the data is there. That means the main data will be remain the same. The whatever the changes is done in the delta, then it's again between the new main data, right?
Correct. That will be a delta march. There will
Yeah,
be a
delta.
operation delta march. Okay. If you see
Yeah.
delta march,
Uh,
so this delta march will come later on. Details.
yeah.
We'll
Yeah.
go.
Yeah.
We'll go in the HANA architecture.
Yeah. Understood.
Because see, if we keep the change data all, in the delta itself, then obviously the main will never have the change whatever we are making, right? Some of the other time we will have to bring this change data to the main data to have a consistent database or consistent data whatever you are having. So that particular process is called delta merge. When the delta or the change data and the main data will be merged together and a new main will be created. Uh, if you consider a DBMS, it's this particular picture of DBMS, it's like a very generic one. It's not very much. You have a database instance. So if you work with Oracle or whatever database, it will have an instance and it will have that database. Now, database is a particular part of DBMS, which is like the passive part. It only holds the data. But to do operations on this particular data, you need to do some operations delete or whatever the operations you want to do on this particular, you need particular process, right? And you also need some buffers, memory, where you'll be keeping the data temporarily for some calculation purpose, which is nothing but the database instance. So database instance consists the processes and the memory buffers, and here we have the passive part of the database. So this particular architecture of DBMS is like a very generic one. So for SAP HANA also we have the same thing. Now, if we talk about SAP HANA main components, so this is how, if you say the SAP HANA architecture wise, it is having this particular components. So first component I want to talk about is the name server. So these are known as servers. So once I able to have the access to the servers and all, I can show you this particular processes. So it will run as a process. So it's not like you will be installing it as a separate server or anything. So HANA is calling it as a server, but if you see the HANA engine, it will run as a particular process. So what this name server does? So this name server actually maintains the topology. It keeps a track of the whole database. Like you can have a HANA database which will be multi-host, because for example, if you have a system of let's say 10 terabyte, but due to hardware constraint you cannot have a 10 terabyte of memory. So what you will do? So in that case you need to have a multiple host. Like in SAP you have multiple instance, so here you have a multiple host. So you can have, like for example, 4 database with 4 nodes. Let's take 2 TB or 2.5 TB each. So this particular database will be spread across 4 or 5 nodes, right? So somebody needs to be there to keep a track, because when you are storing a table, you can store it node 1, you can store it to node 2, you can store it to node 3 or node 4. So who is there to keep a track of this particular tables? So this particular part is been taken care by the name server. Next we have is the index server. Index server is the main component of SAP HANA database. Why? Because this is the server that actually holds the data, and this is the place where actually the operations on that data happens, whatever operations you do, based on the basis of the request from the particular client. So this we'll discuss more deeply on this particular index server. Then we have the compile server. Compile server is like SAP HANA has some stored procedures, standard procedures. Like when we are doing anything, it will have some predefined procedures. So these procedures are being run by the compile server. So this compile server is nothing but it will run the stored procedures that SAP HANA is having. Preprocessor is nothing but when you feed any unstructured data, like if you have a data source which is having a flat file, or if you are having a data source from, let's say, a internet, where you are fetching data from any social site. So it will have unstructured data, right? So what this preprocessor server will do, it will put in a particular structure which will be fed by the SAP HANA database for further analysis. And the one we have here is the access engine. What is this access engine? Access engine is nothing but, you can call it as a application server. As you remember, I told you that SAP HANA has the capability of application server. It provides you a platform where you can develop your own applications. Let's say, for example, you develop a search engine based on Java. So this access engine will provide you the platform where you can develop this search engine on Java, and you can use the SAP HANA database as its database, or it's up to you. So this is how the access engine comes into picture. And if you want to access the database through any HTTP or through any other, if from internet or any other client tool, so you can do it from access engine. So like if you see the picture over here, when we have the DBA cockpit, we have the HANA Studio, or we have the HANA cockpit. The main services, like from HANA administrator perspective, you should be looking into is this particular services should be up and running. One is the daemon, one is the name server, one is the preprocessor, second is the index server, web dispatcher, access engine, and the compile server. So we already discussed on the index server. Let's discuss about this daemon. Daemon is nothing but, this is a particular process which keep tracks and make sure that all the necessary server processes of SAP HANA are up and running. So there will be a server, a particular process which will be running to keep a track, so that all the necessary process like index server, name server, preprocessor, compile server, this processes should be up and running. So this is what daemon does. And web dispatcher, as you are already from SAP background, I guess you know the role of web dispatcher. So web dispatcher is nothing but it handles a traffic from internet, or any HTTPS traffic that is outside the LAN of the customer. Like for example, if you want to have an application that will be interacting with SAP HANA which is running on internet. So in that case, obviously that inbound traffic will be HTTPS, right? So to handle this particular HTTPS requests and all, this is where the SAP web dispatcher comes into picture. And SAP Snapshot SRV, as like it's not like very much SAP HANA specific. If you have seen other SAP products also, you will see that Snapshot SRV will be running. This is nothing but it is used to stop and start the SAP HANA services when the SQL is not working. For example, if your database is down, right? So if the database is down, then you won't be able to have a SQL connection to the database, because the index server will be running. So in that case, what happens is you can connect to the database with the help of this SAP-STAT SRV, and you can do some troubleshooting over there. Now for SAP Extended Application Service Engine, first of all, I would like to say that this particular services that we already discussed over here, this Access Engine, this is an optional one, because it is not mandatory that this has to be up and running. Like if you want to use, if you want to develop any applications on SAP HANA, or if you want to access the SAP HANA over internet with some, with like there are some applications, then only this is needed. So what happened is with SPS 11, for this extended access engine, SAP released extended version. So this is nothing but this will have some more enhanced features of the classical model of SAP HANA. So this advanced model, you will have to install it separately. So it doesn't comes with the default, and this can be installed either on the same server where you are running SAP HANA, or it can be installed on any other server as well. So this can be, this is like a separate server processes that will be running. Now, as I said, that index server is the main core, or you can say the heart of SAP HANA. So this is like a more detailed architecture of the SAP index server. Now, if you see, like we have an interface over here, which is the external interface, which we, SQL interface, MDX, web interface. So, as I said, that whenever you will be interacting with SAP HANA, the communication with the SAP HANA will be handled through the index server. Now, within index server, there these external interfaces will be handling this particular request. Like for example, if it's a SQL, if the incoming request is SQL1, then SQL interface will be used. If the incoming request is MDX, then it will use the MDX interface. If it's something web related or any web applications running, then the web interface will be into picture. So this particular layer, I will say, handles the request from the clients on the basis of the type of request. Now, if we go bit down, this will be the request processing and the execution control. Now, the request processing and the execution control is the main area where the processing happens. Now, when a particular request comes, it first analyzes the kind of request, whether it needs a SQL operations. It requires like it's not given a area. If it's like a text based or any search based or any spatial kind of operations, so this kind of operations will be happening on this particular request processing and execution control. This OLAP engine, for example, if it's a OLAP kind of operation, then OLAP engine will be used. If it's a row based kind of any calculation, then row based engine will be used. If you are doing any joins, because there will be some join operation between the tables for OLAP kind of operations, in that case the join engine will be used. So in short, this particular part of the index server handles the main calculations or operations that are that needs to be done by the SAP HANA. Now, this particular relational engines, this particular layer is nothing but the memory where actual data is being stored. So this particular column store will store the column based kind of data, and row store will store the role based particular data. So this relational engine part is actually the data, the area in the memory is on the RAM where the data is being stored. Now, storage engine, this particular layer, what happens is, like, let's say, if SAP HANA is to store only data on the memory, okay. So what would have been the issues? Can anyone tell me? Because we all know that SAP HANA stores the data on its memory, right? So what are the demerits of it? Let's say it doesn't have any other layers or anything. It is storing the data solely on its memory. So what would be the demerits of it, or what will be the implications? Because you are from basis, so I'm asking you. Because everyone knows that SAP HANA stores its data on the memory, right? So do you think that it only stores the data in the memory? And if it is so, then what are the challenges we might face?
There would be unwanted access to the data, and unwanted space would be occupied.
No, no, no. How come
I think
unwanted? The access will be taken
because
care
the
by
whole amount of because the whole amount of data on the hard disk will be stored in the memory, and the actual data which needs to be accessed by the query is minimum, so there would be wastage of the resources, I guess.
we all know that SAP HANA stores all its data on the memory, right?
Right.
Yeah.
So if it is only maintaining the data in the memory, then what would be the challenges that we will face? It has, see, if you say about the processing of the data, anyhow it is storing the data in the memory. So there is no wastage of resources. Whenever you need it, just pull the data. This is the architecture of SAP HANA, right? So it stores all the data in the memory. So what would be the issue if it solely stores the data into the memory? Let's say we have a shutdown on the server. We have a power failure or the system crashes. So if we are storing the data solely on the RAM, RAM is volatile, right? So then HANA will lose all its data. Then how will retrieve the data if it's storing all its data on the RAM? Because obviously there can be a power failure. You need to restart the database also. When you are restarting the database, then obviously all the memory and everything will be flushed off. Then how the database will sustain? For this, what SAP has done is, obviously you need to have a alternative. Like when you will be starting the database, you need to have the database as like any other traditional database. You should be able to retrieve the database. For this, there is another layer which is known as the persistent storage. Persistent storage is nothing but it's again a particular layer which will have a hard drives, just like any traditional database, where it will keep a copy of the data. So if you see this particular layer, there is a data volume and there is a log volume. If I had this server access, I could have shown you. But anyhow, once we get it, I will show you the file system. It will be more clearer. So if you see the disk storage layer, it is having a data volume and a log volume. Now this data volume is nothing but our hard disk where you are storing the data just like any other traditional database. So even if the power goes on, if the database shutdowns, the memory get flushed, the whole RAM get flushed, you still have the data on these data volumes. Now this, there is another volume which is the log volume, right? So why log volumes? It is again the same thing. We know why we take logs, right? Like for example, if you want to restore the database to a particular point in time, let's say I want to restore the database yesterday 12 p.m. So in that case, you need the logs to apply the logs, and you need to bring the database to a particular state that you want, whether it can be till the recent state or to a point in time recovery. So in for that, what happens is it stores all the logs over here. So with this, what happens is even if the total memory of the database get flushed off, when the database starts, it will get the data from the data volume, it will apply the log from the log volume, and you will get a recent state or whatever state you want. When the database was started, you will get the same state of the database. So to handle this particular communication between this persistent storage and the relational engines, this storage engine layer works, because this layer keeps a synchronization, because all the data that are being read or any editing, any insert, whatever is happening on the memory or on the relational engines. The same data has to be replicated to the disk, because at the end of the day, there should not be any inconsistency. So this particular page management and all is being taken care by the storage engine. So this storage engine is nothing but it acts in between the memory and the persistent storage. So now there are other engines as well, like the session management, transaction management. So what this session management does is it manages the sessions. Like you can have multiple sessions, like SAP in SAP in any SAP applications, you can have multiple sessions with SAP HANA, right? So these are being taken care by the session management. Transaction manager is nothing but which takes care of the transactions that is happening, because it needs to keep a track of the transactions that is happening on the SAP HANA. So this transaction manager keeps a track of the transaction. Authorization manager is nothing but it takes care of the authorization. SAP HANA has its own authorization engine. So like it has more fine-grained authorization over SAP HANA. So it needs to have a separate authorization management, I would say, to implement in SAP, because like SAP HANA acts as a platform, right? So you can have application which you want to develop on the SAP HANA. So in that case, authorization becomes very crucial. If you're using SAP application and you're using SAP HANA as a database, still it doesn't matter because the authorization being is handled on the application. But for example, if you are developing an application which is solely based on SAP HANA, so in that case, the authorization becomes very crucial. So SAP has its own authorization engine as well, which has been taken care of by the authorization manager. Metadata manager is nothing but it take care of the metadata of the SAP HANA, of the tables, like whatever tables you have, or whether it be row based, column based, and different things. So this takes care. This has been taken care by the metadata manager.